Welcome to our channel. Today we are going to discuss about the latest and most exciting stories from the world of astronomy and space exploration. Today we have 5 amazing news items for you, ranging from the largest cosmic explosion ever seen to the first detection of benzene in a planet-forming disk. Let's get started. The first news item is about the largest cosmic explosion ever seen by astronomers, which has been raging for more than 3 years and is 10 times brighter than any known exploding star or supernova. This explosion, called AT2021 LWX, was first detected in 2020 by a telescope in California that scans the sky for objects that change in brightness rapidly. But it wasn't until 2022 that astronomers realized how far away and how bright it was. It turns out that this explosion is happening 8 billion light-years from Earth, which means we are seeing it as it was when the universe was only 6 billion years old. But what could cause such a huge blast? Well, one theory is that it involves a supermassive black hole and a giant cloud of gas. A supermassive black hole is a massive object that has such a strong gravity that nothing can escape from it, not even light. A cloud of gas is a large collection of atoms and molecules that can form stars and planets. Sometimes, these clouds can be thousands of times bigger than our sun. The idea is that this particular cloud of gas was somehow pulled off its orbit and fell into the black hole. As the black hole devoured parts of the cloud, it released a lot of energy and created shock waves that heated up the remaining gas around it. This gas then glowed brightly and emitted radiation that we can see with our telescopes. This process has been going on for more than 3 years, which is much longer than most supernovae or other types of cosmic explosions. This makes AT2021 LWX very unique and very intriguing. Astronomers are still trying to figure out why this black hole started feeding so suddenly and so vigorously. And what are the consequences of such an event for the galaxy and the universe? This explosion is not only the largest cosmic explosion ever seen, but also one of the brightest objects in the universe. The only things that can rival its brightness are quasars, which are supermassive black holes that constantly feed on gas at high speeds. But unlike quasars, AT2021 LWX appeared out of nowhere and could disappear at any moment. This explosion is a rare opportunity to study how black holes interact with their surroundings and how they shape the evolution of galaxies. It also shows us how diverse and dynamic the universe can be, and how much we still have to learn about its mysteries. The second news item is about a new technique that uses a magnified, multiply-image supernova to measure the expansion rate of the universe. A team led by University of Minnesota Twin Cities researchers has used this technique for the first time and obtained a value that agrees with previous measurements based on the cosmic microwave background radiation. This technique could help resolve a long-standing debate about the discrepancy between different methods of measuring the expansion rate of the universe. The expansion rate of the universe, also known as the Hubble constant, tells us how fast space is stretching over time. It is one of the most important parameters in cosmology, as it determines the age, size, and fate of the universe. However, different methods of measuring this parameter have yielded different results, leading to a tension in cosmology. One method is based on observing distant objects such as supernovae or quasars, whose brightness or distance can be calibrated using standard candles or rulers. Another method is based on observing the cosmic microwave background radiation, or CMB, which is the leftover heat from the Big Bang that fills the entire sky. The problem is that these two methods give different values for the Hubble constant, about 73 km per sec per megaparsec for distant objects, and about 67 km per sec per megaparsec for CMB. This difference could mean that there is something wrong with one or both methods, or that there is some new physics beyond our current understanding. The new technique used by the researchers combines both methods by using a special type of supernova that is magnified and split into multiple images by a massive galaxy acting as a gravitational lens. By comparing the brightness and time delay of these images, the researchers can measure both the distance and the expansion rate of the universe. This way, they can avoid some of the uncertainties and biases that affect other methods. The researchers applied this technique to a supernova called IPTF16GEU, which was discovered in 2016 and is located about 4.3 billion light-years away. They found that the Hubble constant from this supernova is about 69 km per sec megaparsec, which is consistent with the CMB value and within the error range of both methods. This result suggests that this technique is reliable and robust, and could be used to measure more supernovae like this in the future. The researchers hope that by increasing the sample size and reducing the uncertainties, they can narrow down the range of possible values for the Hubble constant and solve the cosmological tension. This technique is also a powerful tool to test different models of dark energy, which is the mysterious force that is driving the accelerated expansion of the universe. By measuring how the expansion rate changes over time and distance, astronomers can constrain the properties and nature of dark energy. The third news item is about an unusual galaxy system with a long, highly collimated tail of gas and stars. An international team of astronomers has discovered this system as part of the DESI Legacy imaging surveys. The system consists of a pair of galaxies and an extended tail that stretches for more than 1 million light-years. The astronomers think that this system is the result of a close encounter between two galaxies that triggered a massive outflow of gas and stars. Galaxies are not isolated in space, but interact with each other through gravity. Sometimes these interactions can be violent and lead to mergers or collisions between galaxies. These events can have dramatic effects on the morphology, dynamics, and evolution of galaxies. One of the effects of galaxy interactions is the formation of tidal tails, which are elongated streams of gas and stars that are pulled out from the galaxies by tidal forces. These tails can span hundreds of thousands of light-years and contain a significant fraction of the mass of the galaxies. The system discovered by the astronomers is an extreme example of a tidal tail. The tail is very long, very thin, and very straight, indicating that it was formed by a very fast and very close encounter between two galaxies. The tail also contains clumps of gas and stars that could form new dwarf galaxies in the future. The astronomers estimate that the encounter happened about 100 million years ago, and that it involved two massive spiral galaxies with masses similar to our Milky Way. The encounter was so energetic that it ejected about 10% of the mass of each galaxy into the tail. The system is located about 500 million light-years away from Earth, in a region where galaxy interactions are common. The astronomers plan to study this system in more detail using spectroscopy and radio observations to learn more about its kinematics, composition, and star formation history. This system is a rare and spectacular example of how galaxy interactions can shape the structure and evolution of galaxies in the universe. The fourth news item is about new images from NASA's Perseverance rover that may show signs of what was once a wild Martian river. The rover has found evidence that a deep and fast-moving river once coursed through Mars' Jezero crater, where it landed in February. The river was part of an ancient lake system that could have hosted microbial life billions of years ago. The rover will explore this region and collect rock samples that could reveal clues about Mars's past habitability. Mars was once a wetter and warmer world than it is today, with rivers, lakes, and oceans covering its surface. One of these bodies of water was a large lake that filled Jezero crater, a 28-mile-wide, 45-kilometer-wide basin located near the Martian equator. This lake had an inflow channel and an outflow channel, where water entered and exited the crater. The rover has been driving along the inflow channel, which is called Neretva Vallis, since April. Along the way, it has taken high-resolution images of the rocks and sediments that were deposited by the ancient river. These images show features such as crossbedding, pebbles, and ripples, which indicate that the river was deep, up to 10 feet or 3 meters, and fast, up to 10 miles or 16 kilometers per hour. These features also suggest that the river was turbulent and variable, changing its course and speed over time. This could have been caused by factors such as climate change, volcanic activity, or tectonic movements on Mars. The rover's main goal is to search for signs of ancient life on Mars, especially in places where water was present and stable for a long time. The ancient lake and river system in Jezero crater is one of these places, as it could have provided a suitable environment for microbial life to thrive. The rover will eventually reach the delta, where the river deposited its sediments into the lake. The delta is a prime target for the rover, as it could preserve organic molecules and biosignatures that could indicate the presence of past life. The rover will also collect and store rock samples from different locations in the crater, which will be returned to Earth by a future mission. These samples could provide more detailed information about the geology, chemistry, and history of Mars. The rover's exploration of Jezero crater is a major step in understanding the habitability and astrobiology of Mars, and could answer one of the biggest questions in science. Are we alone in the universe? The fifth and final news item is about the first detection of benzene in a planet-forming disk around a young star. An international team of astronomers, including several Dutch researchers, has observed this molecule using ESO's Very Large Telescope. Benzene is an organic compound that is considered a building block for more complex molecules such as amino acids and DNA. The detection of benzene in a planet-forming disk suggests that organic chemistry is active in these environments and could play a role in the origin of life. Planets are formed from disks of gas and dust that surround young stars. These disks are rich in different kinds of molecules, some of which are organic, meaning that they contain carbon. Organic molecules are essential for life as we know it, but their origin and evolution in planetary systems are still poorly understood. The astronomers used a spectrograph called CRIRES Plus to observe the infrared spectrum of a star called HD 163296, which is located about 330 light-years away from Earth. This star is about 5 million years old and has a massive planet-forming disk around it. The spectrograph detected the signature of benzene, which is a ring-shaped molecule made of 6 carbon atoms and 6 hydrogen atoms. Benzene is one of the simplest organic molecules and can form more complex ones by combining with other molecules. The astronomers estimate that there are about 10 billion molecules of benzene in the disk, which is equivalent to about 0.1% of Earth's mass. The benzene is located in a warm region of the disk, about 10 astronomical units from the star, where the temperature is about 200 degrees Celsius or 392 degrees Fahrenheit. The astronomers think that the benzene was formed by a process called photochemistry, which involves the interaction of ultraviolet light from the star with other molecules in the disk. This process could also produce other organic molecules that have not been detected yet. The detection of benzene in a planet-forming disk is important because it shows that organic chemistry can occur in these environments and produce molecules that are relevant for life. It also raises the possibility that some of these molecules could be incorporated into planets or comets that form from the disk and potentially seed life on other worlds. This discovery is a milestone in the study of organic molecules in planetary systems and could help us understand how life emerged on Earth and elsewhere in the universe. That's all for today's Cosmic News. We hope you enjoyed this video and learned something new. If you did, please give it a thumbs up and subscribe to our channel for more astronomy and space news. And don't forget to hit the bell icon to get notified when we upload new videos. See you next time.